Hi, welcome to the Mathematics in my channel. Today we are going to solve another interesting integral question. Okay, the question is if f of x is equal to x plus sine of x, then find the integral of inverse f of x plus sine of x from 5 to 2 pi. Okay, how to begin? Well, first I am going to take this integral is equal to I, so we can write I is equal to pi to 2 pi inverse f of x plus sine of x dx. Okay, then here we have inverse f of x, so then I'm going to define the integral. So I'm going to take j is equal to integral from pi to 2 pi inverse f of x dx. Okay, then to evaluate this integral of j, I'm going to take a substitution. So if we take x is equal to f of y, then differentiate, so dx is equal to we know differentiate f of y, so f dash of y dy. Okay, now we should change the lower limit and upper limit. So lower limit, when x approaches to pi, we know x approaches to pi here, x approaches to pi, sine of phi we know 0, so f of 5 f of pi is equal to pi, and also we know now y approaches to also pi. Okay, now upper limit, when x approaches to 2 pi, we know also here f of 2 pi is equal to 2 pi, and also y is equal to 2 pi. Okay, now here we can plug in, so we can write now j is equal to limit also pi to 2 pi, pi to 2 pi, and here inverse f of x. Now we know x is equal to f of y, so inverse f of now x is equal to f of y. Now dx is equal to f dash of y dy. Okay, now we can simplify here, pi to 2 pi. Now inverse f of f we now get cancelled, and here we have y times f dash of y dy. Okay, then we need to f dash of y. Now we know f of x, so we can write f of y. So f of y is equal to we can change the variable, so y plus sine of y. Now we need to f dash of y, so now differentiate, so f dash of y is equal to 1 plus cosine of y. Okay, then we can plug in here, so here integral from pi to 2 pi. Now here y f dash of y we know 1 plus cosine of y dy. Okay, then we can write this is equal to pi to 2 pi. Now y plus y cos y dy, we can multiply by y, so here we can write y dy plus integral from pi to 2 pi. Now here we have y times cosine of y dy. Okay, then I'm going to write here this place, so we can write now j is equal to, now integral of y, we know y square over 2 limit pi to 2 pi, then plus here pi to 2 pi y cos y. Now we can integrate y parts, so we can write here now pi to 2 pi. Now I am going to take y as a first function, so y here d by dy, sorry, d by dy. Now integration of cosine of y, we know sine of y here dy. Okay, then we know we can simplify this. If we plug in 2 pi, we know 4 times pi square over 2. If we plug in pi, so minus pi square over 2. So here we have 3 times pi square over 2, and here we know product of these two functions, so plus y times sine of y from pi to 2 pi, then here minus, sorry, here minus sign, and here we have now limit 5 to 2 pi. Now rewrite this function, so sine of y, now derivative of first function, so 1 here dy. Okay, then here we have 3 times pi square over 2. Now we know if we plug in lower limit and upper limit, this term is going to be 0. So here we have 3 pi square over 2. Now here minus, now we can change the variable, so we can write this is equal to integral from pi to 2 pi, here sine of, now instead of y we can plug in x, so sine of x dx. Okay, then I am going to take I, this integral, so I is equal to we know I is equal to integral from pi to 2 pi here inverse f of x, so inverse f of x dx plus sine of x dx, so here pi to 2 pi sine of x dx. Okay, then we know I is equal to now this is equal to, we know our integral j, so now j is equal to 3 times pi square over 2 minus pi to 2 pi sine of x dx plus here pi to 2 pi sine of x dx, and this term get cancelled, and I is equal to 3 times pi square over 2. Okay, this is the answer. If you like this video, please subscribe this channel. Thank you for watching.